Cool. So I'll make a start. So I'm David Williams. I'm a teacher at the British International School of Washington down in DC. I teach like a combination of computing and engineering. A course which we've affectionately known as ITEM, standing for Integrated Technology, Engineering and Manufacture. The course kind of came about because if you do 3D design, well, is that really computing? Is that engineering? If you do robotics and you're doing the programming, but you're making stuff, it's such a fuzzy term nowadays between what is purely computing and what is purely engineering. We kind of just stuck the two together and have way more fun doing it that way. So what we're actually going to do today is go through a little unit of work which we refer to as My Buddy Robot. So what the students end up doing is going through a tutorial like I'm going to give you today, where it gives them all of the fundamentals of Tinkercad to get you pretty much set up and making stuff quite happily on your own. So this is kind of based on the old, like, 80s, 90s, 70s, whatever sort of action figure toys, where there's a card, there's an object inside, there's a barcode, and it looks amazing, and you go into a shop and beg your parents because it's the most important thing in the whole entire world. But very much based on the my love of sort of Star Wars toys, and obviously when I grew up, the Ninja Turtles toys as well, which are great fun. So what we're going to do today is we're going to come into Tinkercad. Now I'm going to go through a small, like little tutorial section. I'll give you some time where you can then make that yourself. If you want to put in the chat done or something like that, that really helps me out. And here we go. So here is our actual robot that we're going to make. I'll go through some considerations of design at some point over the session. You can see this one here, which I've now combined into one single object, but you can see here all the different parts of that object before they're combined and exported as an STL. So what we're going to do is we're going to start off with making this body shape in here. Now, when I run this with students, we all run through it the same thing, and I sort of get to a certain point and go, right, now it's up to you to customize it. So stick with following what I'm doing so far, and it's going to help you out a little bit. Okay. So the first thing we're going to make is this red body in here. Now I'm going to drag and drop where it says box into the main area, and I can resize my shapes using these tabs on here. Now, one really useful feature, if I hold the Shift key, is I can proportionately resize this object. If I let go of the Shift key, I can sort of adjust it into 1 millimeter increments as I go through. So what I'm going to do is going to make myself a kind of not quite as wide as it is tall body shape. And as I go on to it, you'll notice this little pop-up menu up here, up on the top, appears where it says shape. And that allows me to adjust things like a radius. Now, pretty much I can make it a circle, but I'm just going to round off the corners a little bit. For one, it makes it a much more tactile object, but also just it's a little bit safer if anyone scratches themselves with it and those sort of things. So I tend to always round off the corners and shapes. Now what we're going to do is we're going to build one of these vents on the front. So again, I'm going to use this box shape, drag this one into the middle, resize this how I need to. Okay. Now at that point then, I'm also now going to increase the radius to make it nice and rounded. And I can use this upwards black sort of triangle, and then I can position that over the shape sticking out just a little bit. And also you can resize it once it's on there, if I need to. Now what you'll notice is I don't have an option to stretch it downwards, so I've got to bring it down with a black arrow and then stretch it back up on here. All right. Cool. So we'll hold off on that point. So now you've got yourselves a couple of minutes just to drag two boxes across and put a vent on the front like I'm showing here. Yeah, rounding corners again. So once you've got your shape and you drag this one in, there's a tab that opens up at the top. So if you click onto the shape, that sort of sub-menu appears, and then where it says radius, you can adjust that number there to round over the corners. Yes, Janet, yeah, just absolutely. Just as long as it looks proportionally correct, don't worry about it being any specific size. The wonderful thing of Tinkercad is you can always resize things after. And if you're 3D printing them, your slicing software will also allow you to resize and reshape. As a side note, I tend to teach this as a first intro to 3D design. The next unit of work goes into functional prints, where we then actually do start to make things with dimensional accuracy and precisely in the 3D model. But for this one, it wouldn't matter if you made it 20 foot tall, 30 foot wide, because we'll resize it anyway. Cool. So I'm going to move on to the next section. So we've kind of become experts now on the box. So we're now going to bring over cylinder. Now, Tinkercad, when you bring in shapes, if you notice on here, it's actually got quite a few edges onto it. So what I'm going to do is increase the amount of sides, and that then it makes it much more of a true cylinder, round shape. Tinkercad doesn't tend to make things perfectly round. Just the geometry and complexity of the STL file, I think, doesn't do it any favors being completely web-based. So what we're going to do is we're going to add on a couple of buttons onto the robot, because obviously robots have got buttons, and that's very important. Now, when it comes to actually aligning things, see on here, there's like an arrow, and that's now tipping forwards and backwards. There's another one here, which now we tip this way, and also down here is rotate. Now, this one is quite easy to spot this differently. So if you notice, my arrow is closer to the object, and that's then going to jump at bigger increments and put me at basically a standard sort of 45 degrees, 90 degrees. If you were to move further away from the object with a mouse, I can actually go 1 by 1 in degrees. So I'm going to stay close to the object and then rotate this forward to 90 degrees. And then from there, I'm going to add a small bevel and probably increase the amount of segments as well. You can sort of notice just about on there, let's see the amount of like steps which come in, and it basically gives me a much nicer, rounder button. I'm going to use that Shift key again, and then I'm going to position that over the body of my robot and lift that one up. Now, if you want to add in a couple of different buttons, you can always copy and paste once you selected it, Control-C, Control-V, and then you can reposition those as you need to. Now, one little note which is useful for a lot of people is that if you want to make little steps, you can also use the arrow keys on your keyboard. So I can go left and right. You can do up and down, it goes forwards and backwards in space. So just notice that one, and kind of tap a key and go backwards and forwards to work out the best place for it to be. Now, because this session here is with MatterHackers, I'm going to modify mine a little bit from yours and just add on the MatterHackers logo on the front of mine. For your good selves, stick with buttons. Rotate is once you've clicked onto an object, there's little sort of tipping arrows, and then you can rotate around. Close to the object does it in 15-degree increments, whereas going further away allows you to adjust 1 by 1. So now we've got kind of the robot shape. What we're going to do now is just remove a little section here from this panel. So that's a new step, which is going to be doing remove. Now, what you'll notice here on the top, there's these gray shapes with a sort of stripes across. Now, those are used for removing, but any shape can be used for removing. So again, I'm going to stick with box. And then here, now it's a solid, I'm going to put it as a hole. Now, what that allows me to do is overlap that with another shape and then combine those shapes, and then the hole gets removed. So I'm just going to show you briefly on here. Look, I'm going to overlap this on here. And if I was then to drag over all these objects and make them a solid or group, see, that's now kind of sliced that section out. I'm going to press Control-Z to undo because I didn't want to take off that much. Tinkercad's got a huge amount of steps of backwards and forwards. You can actually pretty much go back to the first stage. But any shape can be used as a remove. But what I'm going to do is going to try and very carefully position a hole into that vent there. And again, I'm going to drop that one down using that arrow to then bring that one up. Now, in this instance, it is actually quite important how far that hole goes through that vent. So what I'm going to do is hold Shift and click onto the shape and the hole and then group. Oops. Okay. Now, seeing there, it hasn't taken out enough, so I'm going to go Control-Z, and I'm going to position it again using my arrows and make it go a little bit deeper into that shape there. And I'm going to try again with Shift and group. Ah, there we are. So now I've got a nice vent-looking shape in there. I'm just going to show that again because that's quite a few steps. So I'm going to grab that one. I'm going to grab box, bring this one across, reshape it so it's a nice vent shape to go in here. See, it's my yellow vent over there. Turn it into a hole over on my submenu up on the top right. And then I can position that and resize that one over here. And then I can hold Shift whilst I click on the two different shapes and then group them. And now I've got a vent shape cut out in the middle. And obviously I could have added a rounded shape on there, wouldn't really matter too much. A question I very, very often get from students is, will it print out in the colors which I've put onto Tinkercad? Generally, once I've shown students a couple of spools of filament, they kind of understand. But also, it was, my response sometimes, if I was to use a green crayon and draw an orange fruit, it's still going to come out in green because that's the color which is actually in the inside of the pencil. 3D printing is the same, but obviously then that doesn't stop them from painting their 3D objects. And at the end of the session, I'll give you a couple of tips on painting them and making them look really cool. So the next little section which we're going to make down here is these legs. Who's written a book on this? I think it's mostly videos and tutorial videos we can get a lot from. From the videos, to answer your question, Linda, there's so many updates to Tinkercad that it's probably better to follow videos and tutorials. What I've tried to do with this unit of work is to introduce pretty much all of the major components which are in Tinkercad within one object. So once you've been through this session, you're actually pretty much got a handle on nigh on everything that it can do. But what we're now going to do is we're going to make these leg sections under here. So for this one, I'm going to grab a cylinder. And I'm then going to grab another cylinder. Now for this one here, I'm going to make this one a little bit smaller. Okay, and this one here, I'm going to shrink this one down and then position that so that it's got kind of a leg going on. There we are. Now, just to add a little bit of contrast, I'm going to leave the segments on the top part, but on the sides, and then on the bottom part, increase them. And so that way, I just got a little bit of contrast between this shape and this shape here. Now, what I'm going to do here is I'm going to move my mouse around And if you press the middle button, like this button on the scroll wheel, you can move the camera around. And I'm going to draw a box over these two shapes and copy and paste. And for stability reasons, what I'm going to do is make those legs slightly overlapping and one slightly in front of the other. And I just find that it gives you, for one, a bigger footprint, so to speak, on there because of that lower section, but also it just makes it look like two different parts as it goes through. So that was just a cylinder with another cylinder over the top. Resize the bottom one, hold shift, one over the other, and I, just for fun, increase the amount of sides on the bottom section, and then copy paste. And obviously we can use that trick of holding shift if we want to select multiple parts. So I press on one, keep my finger on the shift key, press the second one, copy paste. And again, in sort of yes, yeah, so perfectly, yeah. Just make one leg, copy the other leg across. We're not going to make any variants on sides on this one. And again, if your legs have ended up massive, but you've got a tiny body, absolutely fine, no worries at all, because we're going to resize them when we need to. Okay, so we're going to move on to the next section now. So what we're now going to do is combine all of these shapes and position them together. So I'm going to move my mouse around, and that's a left click, and drag around. And I'm going to grab those on there, and I'm going to shrink them down just a little bit. And then I'm going to grab the top part and then lift that one and move that across. Now, what you need to be very, very careful of is to make sure that these shapes actually overlap. It's very easy when students make things. Actually, let me just do Control Z a second. What I'm going to do is drag over those legs and do group, and that's going to make my life a bit easier. Okay. So I'm then going to grab the body shape and then position this above. And then I can move the legs so that they fit underneath and resize them as I need to. Yeah, and that fits in there nicely enough. Now, it's very, very easy for students when they make things in Tinkercad, of there to be sort of a very, very small gap between shapes. Now, what you'll notice on here, when they're looking at them, these two shapes look absolutely fine. You think, oh, print, no problem at all. But if you actually rotate the camera around, there's an air gap between them. And so therefore, when your printer comes to print those two things, it's going to have to put infill and support material between those two objects. So because this is a sort of first intro to these ones, I tend to get students to check each other's work on it and just check for gaps and make sure that everything is genuinely overlapping. And if it's overlapping, when it combines, it makes it into one solid shape. So just when you've got your one, just make sure that that shape is through there. If it's through the print bed, really doesn't matter. But I'm going to fix it. So yeah, Linda, this can be immediately exported to a 3D printer. So we can do send to and share. So I can collaborate with someone. Or what I can do is then export as an STL file at the end. And also then you can do a direct to 3D printer. don't recommend it. I don't recommend necessarily letting your students print whatever they want directly to 3D printers, but collecting in the STL files is a very, very good thing to do. For one, then that allows you to just combine multiple ones of them on a print bed. We here have an Ultimaker or two Ultimaker S5s, and I can print about 12 of these at a time, maybe 14, depending on orientation. And I will go to orientation sort of stuff at some point very soon in this session, just to give you a few tips on how to best let them print and a few design considerations. In terms of cost, actual filament itself, we use the MatterHackers build series, and we buy many of them at a time. And I think it comes down to sort of $14–15 per kilogram. With a low infill, these it's probably going to come out to less than 10 cents in filament per robot. Printers wise, can scale right the way from $150 for a Creality Ender 3 to 6,000, 7,000, 8,000 plus for much larger, more complicated 3D printers. The one I'm looking at the moment is a Creality Ender 5 Pro. I think that seems a nice halfway between a first printer and a more rigid shape, personally. I'm quite a big fan of the Crealities, and also a massive fan of the Ultimakers. And also then you can have a lot of fun as well if you want to go down the resin printing route. And there we are, yeah. So Tara's put a link to the MatterHackers build series stuff. For us, it prints flawlessly. You do have to tweak the temperature a little bit. I found that the black filament prints at a slightly different temperature to the white filament, by about 3 or 4 degrees. And for Rosie, for painting them, I spray them with some model paint, and then I use a technique which is called dry brushing. I'll get to that at the end. But dry brushing allows you to get that kind of highlighted sort of smoky effect or worn out metal effect on your robots. And you can also then obviously pick out details should you wish. I kind of wish I hadn't painted the eyes on mine. That's a bit strange. But, and it's very easy to do. And I do run little clubs for students and model painting and things, but it's very quick to do. Okay, so what we're going to do, we're going to move on to the next section now, which is building the head of our robot, because, you know, we're most of the way through now. It's got a body, it's got legs, just needs a face and an expression. Now, what you'll notice on my one here is that the head is slightly at an angle and also slightly tipped up. I want to look hopeful about the future. So I'm going to use my cylinder shape. I'm going to increase the amount of sides. I'm going to add a bevel on the top and just add a couple of segments, just so it's, again, got that sort of rounded nature onto it. For one, it just saves students scratching themselves, and also just becomes a much more tactile and nicer feeling object. Now, the mouth shape in here is not complicated, but it's an interesting way of using Tinkercad of combining multiple shapes together. So will students say, oh, I want to make this shape. Right, well, what shapes is that made up of? That's a square shape and a round shape, put them together. So on this one, I'm going to make a box, shrink this one down, grab a cylinder and tip it forwards, the same as we made the buttons up on the top. And I'm just going to shrink that down, bring that one forwards, bring that one to here. And then basically kind of overlap them, give myself some sort of mouth shape. So I'm trying to make that sort of old style sort of Lego expression up at the front. Now again, I'm going to do copy paste. And now I have this mouth shape which I can cut out. And again, like the legs or the bodies, it doesn't really matter how big it is, because once we've combined it, we can then reshape it as we need to. So what I then do, highlight over the top, and then make them into a group, and then make them into a whole. So now I've got this sort of rounded shape here, which I can reposition and resize, and then put through my robot's head to then create a mouth shape. And again on there, I'm going to hold Shift onto the other one, and then combine them as a group, and then it cuts out the mouth shape. I think it's quite a clever little set of steps, those ones. So I'm just going to go Control Z and go through those steps again. So I grabbed the box, reshaped it, just so it's a bit narrower, added a cylinder, tipped it forwards, resized it so it lined up with the edge of those boxes. See, it's lined up on the front and the back. Duplicated it, added it onto the side, combined them all together, and then made them into a whole. Well, that's a lot of steps. And then from there, position that over the robot head, and then group them so it removes that shape. Linda, for movement on these ones, these are going to be static. There are some really cool little components in Tinkercad of making robotic parts. You can also make cogs and wheels and various other things which are really cool for robotics. If you want to combine this more with robotics and animatronics and those sort of things, there's some really cool stuff you can do with that one. But I have had students make things for a combination project with Spiros. We have the Spiro RVR models here. And we sort of made little robotic arms for them, different wheel fill-ins sort of things. Students have then taken motors and made their own custom wheels, arms, and parts to go off of various solenoids and servos and various other things, which is kind of fun. Jackie, yeah, the type of filament will also depend on how much ventilation you need. I tend to be very, very careful over ventilation with SLA or resin type printing. It tends to affect some people more than it does others. And again, some resins are more abrasive than others to some people. And again, I would not allow any students to come in contact with that physically. We tend to use PLA type filament. That is generally deemed okay to vent to air, whichever classroom you're in. But I also do tend to put my 3D printers in another section of the room or in a different storeroom at the back, still on display. But I think that filament types like ABS, you probably are wise to have either a window open or if you can't have a window open, some sort of jet HEPA filter sort of thing going on close to it. The other one with ventilation is also just to make sure that your 3D printers are not dusty. Tend to avoid other things contaminating my 3D printers and messing stuff up as well. Gloria, yeah, great comment. If you're interested in getting to 3D printing, my contact details will be at the end of this session as well. And from my personal perspective, one of the reasons I became one of the Matter Hackers ambassadors is mainly because prior to that we were buying everything we possibly could from them anyway. We got our CNC machines from them, we got our vacuum formers from them, we got our 3D printers from them. I got all of my resin printers. We buy all of our filament for them. So consequently, it was actually myself that approached Matter Hackers in the end anyway, because we just had great support. Their lifetime support is absolutely fantastic. Their emails are great. But moving on. So let's just finish off the head of our robot on here. So I'm going to go back to basic shapes. I'm going to grab that cylinder. And like I made the buttons on here, you can either copy and paste them across and make the eyes from there. if you want to be a little bit more speedy. Or you could make them again. And again, if you want to kind of modify yours a little bit and make them slightly different sizes, make them slightly different shapes, doesn't really matter too much. As long as you like it, then that's what we're looking for. Okay, and then once you've got the head of your robot, we're going to again combine that as one shape, and I'm going to bring that up and then position that. So see on mine, way too big, so I'm going to hold Shift and resize. Trim that a little bit there, and up onto here. And I'm just going to put him looking up very slightly. So again, rather than staying close to the object, I'm going to come on my resize and tip up very slightly, and then also tip to the side very slightly. Russell, yeah, great question. So for this session, or this unit work is kind of the very first intro to 3D design and 3D making. As well, the fact that Tinkercad works on an iPad and is also completely free is absolutely fantastic. And there's a lot of things in Tinkercad which are very useful. So for example, in Tinkercad, you can actually set up a class code, give that to your students, and then your students can then, whatever they make, you can see what they've made, and then also then you can print it out for them and take those files, which is great. Blender, amazing, fantastic, great piece of software, amazing programming by the many hundreds of people that worked on it. But I wouldn't use Blender as a first intro. And even to my much older engineering students, I still start with Tinkercad just to get your head around making a 3D object and manipulating something. There is a little program called Sculpey GL, which is a first intro to actually brush type printing. If you want to interested in learning about that one, obviously let me know. But Tinkercad is an amazing place to start with and a great stepping stone to other things. Another piece of software which is really great is Matter Control from Matter Hackers, which if you're making stuff yourself, again, I highly recommend. But Tinkercad specifically, having classes and class codes is really useful. And I will just intro that very briefly at the end. So for our robots, just going to finish this session up nice and quick on here. Now the arms, we have been on basic shapes this entire time. Now there are quite a few other things which you can add in. So going back to that step, which was, can we turn this into moving objects? There are things like connectors. So if you want to have ball joints and actual articulated joints in there, rather than controlled, but and your sort of ball and socket joints from action figures and things, then those are really useful. There are characters and character sets. I discourage students from using those because I'd rather they made themselves things from scratch for themselves. And also not all of them print particularly well. Like the chicken foot is just a little bit too fragile. And then the spectacles, again, too fragile and too open to print. Now, the hands, again, you can't really manipulate them, so we make our own. Now, in here, let's go into actors and basic shapes. Shape generators. Now these ones are really useful. Now from there, what you can actually do is start to make tubes and pipes and various other things, which is what I did with the arms up on here. which is currently failing to load, which is a bit on. But again, like say the spring up on here, what I can then do is set the radius and also then set how many times it rotates around with an offset. I can set various other things. So I can actually get quite technical with some of these connectors in here. And again, so if you want to make propellers for things, again, this one on here, what I can then do is set the arm width. If you wanted to experiment with various things, how many arms has it got? And also then you can have snap sockets and quite a few cool other things as well. Now, for some reason, bent pipe is failing to load at the moment, which is what I use for the arms up on here. And for your students, when they're expanding into this, this is generally the point where I say, well, here's some extra tools, but it's up to you now how you want to finish your robot. Now, what I haven't shown you so far on here is the rear side of it, where I just added in a remove section, and I've kind of just played around with some of these different shapes and characters and like making it home. I think this object here is a spring. This orange one here is a cog. These are various other cogs. Obviously, it would never rotate, but it's a toy. It doesn't matter too much. This, I think, here was the plastic bottle shape. And again, as long as I kind of give the example a bit like Lego. Well, in Lego, a single orange round stud in a kitchen must obviously be a piece of carrot, and a larger one must be a plate. It's down to your interpretation of how things look anyway, and how you want to finish your robots off. Now, from there, a couple of the considerations of when these actually do print out is what I tend to do is tip them back on themselves ever so slightly. I don't know if you can see this. So here's the support material, which is helping this robot print and stand up. But because I've tipped it back on itself, grab that on there and tip this way, it means that the printer, a bit like icing a cake, is going to be a much, much nicer surface on that front. It means the other side of it is going to have the support material, so it's not going to be as smooth, but I'm going to prioritize the front of it looking nice. And again, with your considerations of prints, what I'd recommend is make things nice and chunky and nice and solid and make sure they're connected. And that way then you can kind of really shrink these objects down and how they go through. Now, what I can do on this one, this is my finished one, I go to export, export as an STL, and that file there will open up in a preview. Probably going to take me to the wrong one. No, don't dimension, ignore that. But I can then import that into my Cura and print from there. So for the actual, Linda, for your question on useful prototypes, that's the second stage of what I would do after this unit of work. What I would then have the students do is design a functional piece. And yeah, as Tara says, so once you've gone through this, you can now sort of work out, well, if I am going to make a shape in here, and just go into basic shapes, as I make my shapes in here, as I go onto these objects, I can actually edit these numbers. If I want that 21 millimeters by 26.5, okay, I can actually make things accurately and resize them. It's not going to be as accurate as making something in, say, like Onshape, because that's more of an engineering piece of software, but that's going to take you literally weeks to learn. Whereas this one, if you wanted to make a key fob holder or a key ring sort of mount, or making a piece to go inside of a puppet for doing animatronics, it's going to be accurate enough for the majority of people. And as I say, with this one, you can do this on an iPad, which means that a lot of schools and a lot of students then have this quite accessible. If you want more information on successful 3D prints, Billy Rubin has made some amazing infographics, which I cannot recommend highly enough. And I definitely recommend you put them up in your classrooms because they are fantastic. You can get them printed out. I think she sells them on Redbubble, but you can also just print them out at home. and little guides of CAD design tips for 3D printing, or how big is your overhang, what shapes work. And these are really, really useful. And it also gives some designs of which pieces of software are really good to start off with as well. And also just some sort of general printing tips as well. I was asked as well in this session regarding collaboration. So in Tinkercad up on here, what I do have is my classes. And let's go up onto here, up into classes. And you'll see my different groups down here. And if I was to go onto this class here, these are the students in my group. And I can then go into something that that student has made. And I can see the objects of what they are trying to put together at that stage in there. Let's go into here, 24 days ago, a month ago. There we are. And so this student's been making various things in there. And if you use Tinkercad on the iPad, there's also an amazing augmented reality section as well. So you could actually make an object and position it in the real world and then rotate around it as if it was in the real world. So we use this as a little intro to architecture and interior design. And so students design like sofas or signs or shelving units, and then can physically, virtually place them into a room and use them that way. For this one in particular, as you'll notice here, there is a backing card I made on there. And I made this in a piece of software called Pixlr. And then specifically Pixlr X. And again, Photoshop is probably better, Illustrator is probably better, but within an hour, within a lesson, your students can make something, publish it, print it, and get an object, which I'm a very, very big fan of. Teaching the core skills with not a huge amount of freedom, but also then enough that it can be personal and come back. So what we tend to do with our robots is kind of give them a personality and a little backstory. So the little backstory of my robot, his name's Walter, and because of exposed circuits on the back end, obviously he doesn't want to get wet. And so what I did with my one is drill a tiny little hole in the hand, so he can hold, or she, or whatever it wants to be, an umbrella, so he can stay dry and not keep his exposed circuits from shorting out. And for then the actual carded shape on here was then vacuum formed, and we have a Meiku form box, which allows me to do the actual shell for 5 or 6 of these at the same time. And this is a great piece of hardware which the students love using because they like the big kadunk of the plastic and the turning on of the vacuum cleaner and all the noise, and you end up really nice packaging. And then I bought from Amazon an actual like stamp for making the hanging tags out of. And then when I do this as a unit of work, we make 2. The students leave one with me, they take one home, and then the one which is or they get 2 of these, I keep one of them, that becomes a display board of the toys which they've made as an actual product. So again, your idea of actually teaching product design, you can either do this as a commercial product toy and then end at this point, or you can start to design an actual commercial useful product. So for example, students have made like winders for toothbrushes, assistive devices, clips for headphones, stands for their Xbox controllers, and various cool things, and then designed the backing card and designed those. And then, yeah, exactly that. The kids are very, very keen to make things and sell them. My personal friends and stuff on Facebook and various other things, I've now made quite a few of these and given them away. I also tend to make quite a few robots and just hide them around the school, just because it's fun. And that's the story of those robots. Just trying to think what else to go through. Let's just go back onto here and onto Tinkercad. And you'll notice where I've sort of taught this before, and obviously been through these step by step. Oh, I'm sorry, yes, painting. The paint which I tend to use is a Citadel Chaos Black spray. If you've got a Games Workshop by you, then you can pick that up from there. But any matte black paint is very, very good. I kind of like painting models and stuff in my spare time, so I have this stuff anyway. But once you've then given it a spray, pretty much any acrylic paint is good for painting onto. And then what you can do is a technique which is called dry brushing. So what you use is a slightly wider brush. You dip it very slightly in the paint and rub off most of it on a kitchen towel, and then basically sort of scrape it along the surface. And then what gets left is the paint that's in the middle of the brush, and that then allows you to kind of pick out those highlights. And it very, very quickly looks like you've very meticulously painted across the top of it, when really all you've done is just flick it with a paintbrush. The other thing which you can use is very, very, very cheap nail varnish. The cheaper the nail varnish, the better it works. Magic markers, they also really neat. Tend to recommend spraying the object first just to give it an undercoat, and that just tends to make it a little bit nicer and a bit easier to stick to. But you can also spray them a little bit of hairspray, and that also just allows paint to stick to it a little bit easier as well. Just allows it to have something to key into. And Linda, so the designing cards and selling those. We do a unit later on with our what will be our grade 9 students of product design, and that's exactly up that street, that exactly fun sort of thing. Students coming in and go, "Oh, I made $50 this week," and I think, well done. Yeah, that's cool, and that's really what engineering is about. Making things, and then when someone says, "I'd like one of those," I would love one of those at home, and that's just a wonderful place to be, of making, and it encourages people and it encourages students, and things like craft fairs that you do at your school, of Christmas cards, or whatever events you've got going on is always fantastic to make. Cool, right, I realized that was quite a lot all in one session. In 1 hour, generally, I can get students who have made something, made a robot, good to go. I get the students to come back and check each other's to make sure there's no missing parts in there. And hopefully that was interesting, and hopefully that was useful, and hopefully you've learned some cool things. So this session will be available and be recorded. If you have any further questions or follow-up, I think my details get shared at the end of this one. But also then, if you're interested as well, go through the Matter Hackers education links and emails from there, and we can get connected up. And hope you had fun.